Welcome viewers to E-Pathasala, the lecture series on GIS for PG students of architecture. We have been discussing about data structures, especially the raster and vector, very important structures. Apart from that, as I was telling you, you also have an important data structure, namely the TIN and the DEM, again a raster based data structure, which has got a unique role to play in various applications. I have just given you the introduction. Now, let us see the various advantages, disadvantages, the type of TIN structures, how a DEM is created and other things. Triangulated irregular network, or the TIN we call it as. What does it do? How does it work? As the name indicates, we use n number of triangles here. These triangles are irregular in nature. You cannot have similar shape or size. It is not a compulsion, it does not happen. It is a set, and very importantly, they do not overlap with one another. They are adjacent triangles, and they are normally formed from, say, irregularly spaced points. Obviously, x and y horizontal coordinates, and the most important, the z vertical elevation. For every triangle you will have a x and y and also its z values. What are the major advantage? It can capture the slope factor, the aspect factor, especially in hilly terrains where it is inaccessible in nature. We can use this analogy. It is efficient since we will be in a position to use the less number of triangles in flat terrains. As I already told you, for kind of analysis like slope, aspect and volume, we use this analogy. But the only disadvantage is you cannot analyze or use this and compare with other layers, it becomes very difficult. But you can overlay that. TIN can be overlaid on other aspect features like this, but it cannot be used for analysis. What does it do? How do you get that? You can see that elevation is shown as a raster data top here. At the bottom you have the TIN, how it is divided into n number of cells. And for everything, the TIN rather, you find here again the same context of how you have done in the case of your vector data, starting node, ending node, or the adjacent node, or what are the adjacent polygons rather. For triangle A, if I consider 1, 2, 3, this is the node list. What is the neighbor? B and D. Onto the left is your B, onto the right is D. Similarly, for B, onto the left is your C, onto the right is your A, and it is bound by 2, 4, 3 or 2, 3, 4, does not matter. So, this is how it goes. So, each and every triangle is described with a node as the context. That is what I was telling you. TIN is more of a raster plus vector data. How do you develop that? So, nodes are connected to the wherever you have a nearest neighbor in the form of your edges. Of course, it follows a rule, a set of rule, and it will also represent an uniform area or topographical detail. Automatically at the end of the exercise you will find a network of triangles because you are also using vector data, you can also have the topological relationship for the triangles. As we just seen in the previous case, the left, right, the connectivity, contiguity, all those things can be there. It uses the optimal Delaunay triangulation method for irregularly distributed points, because all the points are not known and we cannot get regular z value or in any case. That is the reason we use your irregularly distributed points, and obviously they are very popular in, say, almost all the CAD and the surveying packages. This is how a TIN will appear. You can see here, and of course, I do not know if you can interpret from here. What you could exactly interpret is that these areas are of lower elevation, broad triangles. these areas of higher elevation, and you can see here the coarser, the harder it becomes for you to identify will be your peak point. So, that is a excellent part of your say a tin model, you can look at it. Why should you use a tin at all? Why do you require a data structure which is basically used for specific purposes? When I have a very small area and I have excellent elevation data, to create a DEM, this becomes a very good important input, and very importantly it can use any kind of input from various sources like GPS, survey data, field data, all this can be incorporated into this. As I told you, very useful for creating a DEM or your contour data. What kind of modeling can be done? Roads and road cuts, in which you are trying to do it in the case of a hilly terrain, dam construction and modeling the same, urban flood modeling. So, these are the major, of course, there are n number of, just a few of them have been listed here. And very importantly, bear in mind, if I have very good input data, namely surveyed small contour intervals or the LiDAR data, a tin will become much more effective. Disadvantages when you have advantages. What is that require? You require very good or accurate input data or source data, because if I want to have accurate source data, what will be the impact? I will have to spend more money. It becomes very costly to create a high precision elevation data. And again, of course, data files are large, it does not matter, it still cost is a factor. And again, when I want to process the data, because I am going to use not only the cost is one part, that is a physical aspect, because I am going to handle large file data, I require computers of high processing power. When DEMs are available, it is easy to use a DEM which is ready made, rather for me to you create a tin and work on that. A vector elevation data, how you can convert, you can see in the next image, just see this, how it is being created. So, we normally what we do is that from the vector data, especially the contour lines, as I was just telling you, every individual topo sheet will have contour lines, provided you have a variation there. You can collect all the contour lines, these contour lines are converted into say point data. Without converting into point data, you cannot create a tin, you cannot create a DEM also. So, what they do is that extract the contour data from your topo sheets. Apart from that, we also have what is called as spot heights, or the points of highest elevation which is not a multiple of your contour value, which will be a unique and individual value. For example, depending upon the type of topo sheet you use, it will be either 5 meter interval, 20 meter interval, which is a very common contour interval in your topographic maps, 50,000 scale. You get 20 meter, 40 meter, 60 meter and so on up to the maximum in that given area. A 50,000 scale topographic map will cover around 625 to 630 square kilometers, and whatever is present within that area, everything is in the form of contours, the 3-dimensional data, whatever is there you can pick it up. Well, apart from that, you will also have what is called, as I told you, the spot height. These spot heights are nothing but the peak points of in a given terrain. You may have a small hillock or a small hill, and the peak point will also be registered as a say your spot height, which will be a odd number, will never be in the form of your say the interval value 20, 40, 60, it will be 64, 84, 93, something like that. Okay. So, we can collect not only the contours, we can also collect the spot heights from topographic maps. So, when I am trying to use that, I told you that you can also have contour lines which are 3 meter intervals, which can be derived from a 5 meter DEM. For visualization it will look very beautiful, but not for analysis part unless it is converted to tin. So, the resulting tin of that terrain, you see here the hilly terrain of what we have seen here, you can see here I think the contours are all very close to one another, hence the variation in the height taken. Okay. So, this is the river part of it and this is the river part of it. You also have a small hill like here. So, a small thing is there. So, that is also taken into consideration. Attribute information. So, when I use the same thing as in the case of your vector data or raster data, even in the case of your say DEM or a TIN, you will have a file with n number of columns and rows. Each row will represent the feature record, each column will represent the attribute detail. Attribute, all of you know that it is nothing but the characteristic details about an object, that is an attribute table. So, an attribute table with the information in the form of your row. Please bear in mind, for every given object when you are representing in GIS, it can contain only one row. You can have any number of columns in a row, but you cannot have more than one row for one object. It could be a line or a point or an area. That is what is the characteristic feature. You can add any number of columns, infinite number of columns, there is no restriction. Most of the GIS software offers up to 250, 260 fields, I mean columns, fields rather, but you cannot have more than one row per object. Then coming to DEMs, digital elevation models, what does it do or what is it exactly and how does it work? You know that all these things, digital elevation models, which I have been telling you repeatedly, is your representation of cartographic information in a raster form. Again, it also contains a array of elevation for any given ground position at regularly spaced interval. Of course, most of the DEMs are provided or produced by USGS, United States of Geological Survey. Many times they also go for a 7.5 minute unit, or they may even go for 15 minute unit, but it all depends on the purpose or application. A 7.5 minutes is a very huge size, whereas if I talk about the DEMs which are being used for say ortho rectification of satellite data, you can't use that. So, normally we go for a 30 meter, or even that is also very difficult to use, but still relatively it will be better, it will improve the positional accuracy of the object, that is the reason ortho rectification is done. So, that we can see sometime later. Digital elevation model, what are the advantages? Just like TIN, it is a very simple conceptual model, very cheap to obtain, get the XY value and the Z value and create it, because all the software will have that. You can also relate it to other raster data unlike your TIN. So, you can have a kind of a interpolation technique. One advantage of using DEM is that if I get a DEM with a 30 meter interval, I can interpolate the data between 30 meters. Of course, that is also a disadvantage or a kind of a error, because you are trying to interpolate between 10 and 20, 11, 12, 13, 1 meter. If I have a 10 meter and 20 meter, if I am going to interpolate into 1 meter, it may not be representing the actual elevation at that particular point, isn't it? Because when I have a 10 meter interval and a 20 meter, I do not know what is in between. You can also have a small valley there. You can't say every intervening point between 10 and 20 meters will be always 11, 12 or 13, 14 around that, but it is not true. But still interpolation techniques are required to complete many projects. That is the reason they go for interpolation techniques. I was just telling you about that, it does not conform to variability of the terrain, and above all it cannot represent linear features properly, because linear features, as you know, that line data also will be a line data, your raster cells. So, linear features cannot be represented, but if you have contiguous features, then it becomes a very good tool. There are various techniques by which DEMs can be generated, like interpolation method, hypsography data, or hypsography is nothing but your contour detail or the height details, and some of the uses of DEM. Say for example, in many of the civil engineering applications, cut and fill volume estimation a very coarse contour map. As I was telling you, if I have a 20 meter, I can create a DEM, and I can also have a 1 meter interpolation using that. A very interesting aspect is here line of sight or the view shed we call it as. An application which is there in say most of the water resources. It may not be directly pertinent to you, but many times when you are going for regional planning, when you are intending to develop or create a new township, it is a must you should know what are the water resources, what is the water availability. We call it the watershed management analysis, wherein which view shed analysis using DEM will be really useful. That is trying to view a specific point away from the point of origin. That is, when I am looking from here, how do I perceive the surrounding area? How do you understand what is present in surrounding area? View shed analysis, a very typical and a very interesting aspect. We also have shaded relief maps which can be prepared from DEMs. I think while doing cartography, I have explained you what is a shaded relief map, how it is being prepared. Of course, small importance is that it requires a appropriate software to read or analyze the data. A good example of a DEM, you can see here how the wire mesh we call it as overlaid on the DEM, and this is the DEM part. So, you can see that. So, how a DEM is created? Advantage is that anywhere you can, if you want to find out the elevation, by pricking on that particular point, you can get the Z values. Apart from X, Y is obvious because you know they are all related to your geographic coordinate system. An example of a 30 meter DEM, and here to here it is, I think the same thing what I have shown here, just enlarged it. A DEM is there. So, a DEM behind a tin. So, how a tin is being used to create a DEM. You can also create a tin based on a 2-foot contour line provided you have the data. As I was already telling you, very important thing is input is important. There is something like intelligent guesswork we have just seen, and I told you about the contours which are being interpolated rather. Interpolation techniques. Interpolation is a method of trying to acquire things which is not readily available to you in the form which is required to us. It may be available in some form. So, for example, I was telling you about the contours 10 to 20 meters. But my study requires, I do not have any other source of data. My study requires a 1 meter contour, a 5 meter contour, or 2 meter, I will have to interpolate the data. So, you require some sort of a intelligence application. That is why it is called as intelligent guesswork, and in general spatial interpolation is referred to as intelligent guesswork. As the name indicates, interpolation, interpolating the data. It is just a process of filling the gaps between the sample observation. Whatever data I have, I will have to fill with the other data. And if I want to have a proper interpolation, I will have to have objects which are as far as possible closer to my study. Otherwise, it will not be possible for me to get a proper interpolation. Nearer things are a key to get a smooth and continuous fashion. What is a good example? Pollution from an oil spill or a noise from an airport. So, these are some simple examples of how you can use that. And if you want to also measure the distance between two sample points, this application actually we have done in one particular interesting aspect is your application for your say elections. When people were finding it difficult to reach a particular point to vote, you cannot say you can't vote because I can't have a polling booth, because that is against the constitution. You will have to have some method. So, fortunately GIS came to our rescue, and we were able to, especially in remote places like very remote places in districts like Udagamandalam or Ooty, we call it as in Tamil Nadu, wherein which this analogy was used, and we were able to locate polling booths which is convenient for many people to converge and come there. If I have at my place, it will not help many people, all the people cannot come and vote there, isn't it. So, GIS will help you to find out distance between 2 points and then have a kind of a solution for some sort of a study related to trekking or a kind of accessibility. So, this is what is your smooth and continuous variation of your, otherwise we call it artificial smooth and continuous variation of your contours. And you know that, as I already told you, this is how a contour is there. A contour can never intersect with one another. Each of them, depending upon the type of map where it is being used, it could be 100 meters or 200 meters or 10 meters, 20 meters. Here it is 100 meters each, 3000, 3100, 200, 300, 400 and 500. This is what I was telling you. Somewhere here, if we have at this particular point one value, that is called as a spot height. Spot height will be here, and that will be 3644 or 3000, less than 3700, because 3700 means one more contour would have come. So, between 3601 to 3699 you will have, and whatever values are there are represented by your contour value. So, what are the advantages of your contours, and how actually you can see here what is a valley, what is a hilltop, what is a ridge, all these things are there. Of course, you can understand when you can read a contour map. What are the advantages of creating a contour? It is always familiar to many people. You do not have to tell how it is there. As I was showing you previously, the closer the lines are, the steeper the slope, the more it appears like a V. You can see here V, it is a stream. If I have the same thing downhill or along the budge, this will be a ridge part. If it is the topmost point, that is a hilltop. But disadvantage is that it is very poor for computer representation. You will not have any digital model. You have to convert to raster or tin for analysis. You cannot use it directly, the contour lines. So, if you have a proper data, you can convert it. Otherwise, you will have to, as I told you, contours have to be converted into point data, and only then it has to be converted into DEM or a tin. So, in that context, you require a good sophisticated interpolation routines, which is available, and Surfer is a good software which can be used, or you can also use ArcGIS Spatial Analyst extension. That is how you can create a contour line. You can never tell that the distance between 10 meter contour and the 20 meter contour is uniform, or the terrain is uniform. You can never tell. It is not possible for one to sit in the lab and then find out what is the terrain between 10 meter and 20 meter contour. It could be a little ridge like, or it could be a valley, or it could be really smooth. It depends on the aspect there. So, normally how do you interpolate? So, when you want to make an interpolation, what kind of a technique and how do you use that effectively? It should be accurate. This method IDW, or otherwise called as inverse distance weighting, is that method which is a very important method and a very precise method, wherein which we try to give importance to the closest points, and you require a good sampling there. Of course, other methods and functions are also present, but IDW will be a very good method. This I have just taken from an ArcGIS, one simple example to make you understand. These are the various points which have been selected, and for its effect we have given the spot values. Very simple attributes of that. These are the various points and these are the spot heights or values. The IDW method, or inverse distance weighted method, how to interpolate the value? Obviously, the system will ask you the points. I have given from layer samples 1, I give the field name spot, and I can decide what could be the power there, power of 2 or 3, and when I say search radius, I was telling you one important thing: the closer the more number of points, the better will be the interpolation. So, I just give the radius, search radius variable. If I give a fixed value, it will search only within that value, isn't it? So, when I say variable, what will the system do? It will automatically try to locate. It will just give a 1 meter and then find out. If it does not occur, it goes for a second meter. So, from one point to another point, if it encounters one more point or third point or the fourth point within a radius of 1 meter, 2 meters, 3 meters, it improves. If I have a point 5 meters away, it may not be as good as a point which is 1 meter away. We tell the system to have a variable search radius, so that will be very convenient. Of course, number of points you can decide as 5 and output cell size 100. So, all these things are straight. Your raster output you can give a, see how it is taken into consideration, that interpolation based on the points I have given. So, these are the points belonging to one value, that is your 1570.9 to 15792. So, higher and higher, this will be the peak point, rather we can't say that. So, of course, when I have a third dimension I can tell you which is the highest point, and as it goes up to this, and it just classifies in the form of a different color for different values. Then what I can do is that for the same value I can go for a hill shading. This is what is the lowest value and the highest values are coming here, this is the peak point. So, hill shading, you see here, of course, it does not show a third dimension, but still hill shading will be there, indicating this is the highest point. Slowly it is decreasing and it reaches a point where it will be the minimum here, 1500 and odd. So, these are the various values. Of course, we cannot get at valley and depressions here, but just a hill shading will give an idea how it has been depicted in the land. Same thing, I can also try to illuminate that. Software will give a facility so that I can put the light from one direction, any direction, and then rotate the objects to find out how does it appear, 3 dimension, 2 dimension, it will be coming out very well. You can see the comparison. You have two different methods, one is a skewed method, one is a unskewed method. So, when you have the unskewed method, you can see how the values are better. When you have the skewed method, it becomes relatively poor. This is a better method, this is a relatively poor method. So, this is how we normally work with your, say, your IDW method. Basically, what you should remember is that interpolation is not an error, it is not a difficult thing, but still it depends on the data inputs what we receive from various sources. The more the number of values, the better will be the accuracy. Very important, when you are trying to classify using ArcGIS or any software for that matter, I told you Surfer, have more number of classes, give a variable search radius. Obviously, what the system will do is, will try to have, when you have more number of classes, that is the, when you have something like a less interval, then it will become much more efficient. Instead of giving 100 to 100.5, give it 100 to 100.1, 0.2, 0.3, 0.4 and then 0.5. So, obviously, I do not say that objects will fall within that range, but definitely it will have a huge impact. So, what we tend to do is that we use good data to interpolate the data, interpolate and then get a excellent contour interpolated output. However, the contour data cannot be directly used for creating a DEM or a TIN. It has to be either converted or it has to be created in such a way that you will have a good 3-dimensional model of the area. That is our digital elevation method. You also have what is called as digital terrain model. A slight difference between that and this is that digital elevation model is just indication of the height variation. A terrain model is additional data, that is a thematic map being overlaid on a digital elevation model, namely a land use map over a DEM to show what exactly objects are present, because a DEM will show only the height variation. But if you want to see what is present land use wise, then you will have to overlay. That is called as your digital terrain model. So, let us stop with this as far as this particular aspect of DEM is concerned. Thank you.